Hello everyone, my name's Ryan, and as before last year I was here asking for people to go on to their land, and I'm here to present the results of my honours research. So first of all, I'd like to say a big thank you to everyone that allowed me to come on and measure the borehole temperature. Without your help, this research couldn't have been possible. So what did the methodology look like? Just essentially collecting the field temperature data, comparing that with outside temperature sources, using spatial modelling, what the spatial modelling trend tells us, and then gathering our conclusions from that. We also compared long-term temperature data sets through water in South Wales to see how stable temperature was over a large period of time. So if you saw me on site on your property, I was probably carrying a metal wire with me and a temperature probe, and this explains what that was doing. So we took what we call a dipper-log temperature and pressure probe, and we lowered it down the borehole at interval depth measurements, usually 25 meters at a time. And then what this would tell us is the temperature and depth of the borehole column to see whether there was points that were hotter or showed a steeper gradient in the temperature of the water there. So these are what the desired results look like. These are from the Botanic Gardens and in one of the sites that we called Colo Vale 1. Essentially, the flat line we see in the total pressure is the equilibrium, or just the steady state of the temperature, and then the red line is the temperature recorded at each depth. So here in the Botanic Gardens, we can see quite a trend, I guess you could say, in a high elevated profile at 180 meters, and then a consistent temperature trend up to pretty much the surface at 25 meters. So these are the things that we were looking for. So overall, we went to 28 different field sites. 36 were from external data points. We went and collected 5 long-term data sets, and so 73 points were used into our 3D model. So this is our first model that is just a statistical model. It's not a predictive model. It just takes the points that we got and visualizes it. So we can see that towards the Mittagong and Barrel and towards the south there, we're getting this cool zone. In the middle, that hot middle point there is the Lake Nepean 1 measurement. And then we also are getting this hot zone up in southwestern Sydney, near Picton and Camden, Campbelltown area. So some people might be thinking, I'm only getting that data because southwestern Sydney is hotter usually. And that's where I was like, good point. So this is the same kind of idea, but instead it takes the difference between the average surface temperature of the area and then comparing that with the groundwater temperature. And as very similar trends we're getting, where you're getting this cooler zone beneath Mittagong and Barrel, that same hot middle temperature in the Lake Nepean area, and then up in the southwestern Sydney, that hot zone. So this next model is a 3D interpretive model that takes all our data. It takes different transects and makes into this 3D block diagram. So what does this look like? Pretty similar to what we were getting with our other model. At 100 meters, the model was able to predict a similar trend of that cooler south zone, the middle hot zone of the Upper Nepean catchment, and that hot southwestern Sydney zone. And then at 180 meters, we're getting this sort of dissipation of temperature up in Nepean, but that's still pretty hot under southwestern Sydney. So in a transect sort of diagram, this is what it looks like. So it almost looks like a sort of thermal plume is coming up from Lake Nepean, and then we're getting these consistently cool zones in the Southern Highlands and hot zones up in southwestern Sydney. So looking at the long-term thermal data sets, these were done in Moss Vale and Sutton Forest. These trends that we're seeing is very stable. So even through these El Nino and La Nina years, the summer and winter temperatures, the groundwater is still at a stable temperature. These jagged up and down boundaries we're seeing here is just because the temperature data is at 0.1 of a degree. So it's probably just going from 15.6 to 15.7 degrees, and so it's going up and down. But overall, we're getting these really consistent trends from 2021 at the start and then to the middle of 2025. So what explains what we're seeing here? So likely the Wianamata group, the shale here, is acting as an aquitard, limiting the movement of groundwater from rainfall. And then we're getting the Hawkesbury sandstone acting as a semi-confined aquifer, so holding this groundwater. And then this is where we're seeing this thermal stability, where we're not really seeing too much recharge in the groundwater at a high pace. That's going to disturb the temperature here. So before I talked about the influence of these intrusives, this map just illustrates where these intrusives are in the state. We can see that in the Upper Nepean up here, we're getting these more extensive units, and then towards the Southern Highlands, we're not getting as many here. And this is just one of the cases we looked at as to why this might be possible. Another one was looking at the Illawarra coal measures in the area. So I'm sorry this diagram is not great, I didn't make it. But the black units here are the coal measures we see. And from the south here is at Sutton Forest. So we're only getting a few accumulation of these coal seams. And then all the way to the north, we're in like the Camden area up here, we're seeing higher accumulations of coal. So this was also another theory as to why we might be getting higher temperatures in southwestern Sydney compared to places like the Southern Highlands. This one. So what this looks like overall is probably the syenite and these coal measures acting as like a blanket almost, where it's trapping this heat. And then above that, we're getting cooler temperatures in these sedimentary rocks. So Lake Nepean 1 does have these syenite layers, and they're recorded in this borehole just around here, around 325 meters depth. We do get these in the highlands, so this is an old borehole from the Midgong Golf Course, and we're getting this pretty extensive syenite layer around 200 meters depth. This is just a visualization of where Southern Highlands sits across the state in terms of thermal temperature. So the blue dots here are the Southern Highlands temperature measurements, and they sit below the average gradient here of temperature. So it's a bit cooler than the state average, I'd say. So I think I want to make one thing clear, is that before we're talking about things like the syenite layers being around 200 meters depth, our research only went to 180 meters. So when we're seeing this cool layer of this cool zone in the Southern Highlands, this may just be because we've only went to 180 meters, and it's not a full conclusion of what might be in the temperature profile beneath 200 meters. So while it may only be cool, it could be a lot hotter than we're anticipating. So I can go to some conclusions. So like again, the Southern Highlands is generally thermally subdued, yet spatially consistent. The Lake Nepean 1 remains the only significant thermal anomaly in the region. Areas north of the Upper Nepean catchment show high thermal stability. Elevated temperatures at Lake Nepean 1 likely result from the syenite intrusives trapping heat from the coal seam, so acting as a thermal blanket. And then at depth greater than 200 meters, the geothermal system is expected to become more complex with greater heat potential. And the region's stable but cool groundwater regime supports potential for more ground source cooling applications in future geothermal developments. So yeah, some limitations: simplified spatial predictions. We used only one thermal predictive modeling software. Data and sampling constraints only went to about, around under 30 properties, I believe. So getting more measurements in the future would be great. And site-specific influences. Sometimes we weren't always able to go to the limits of the depth of the boreholes because the borehole design was often a bit tricky, and sometimes we got stuck. So future research and recommendations, obviously expanding and refining the data that we collected, integrating more geological and hydrological controls, employing more advanced modelling techniques, and strengthening the data nationally. So this is someone's pet peacocks. And then at Berrimah, our equipment got stuck for 15 days, and that was not very fun.
What sort of temperature differential do you need to actually?
I suppose it depends on what you're trying to achieve. So if you're looking for more cooling applications, I suppose something in the more 12 to 14 degree temperature range is probably going to be more viable. If you're looking for more heating applications, it's not going to be as great. Because like I said, the temperature in the Southern Highlands is pretty stable, so you may only get like a season a year use out of it. I didn't do specific water quality evaluations, but we did see some variations in people's water quality. People often had high iron levels in their groundwater bores, but I didn't see any trends in where these high iron were and where they're not, so I can't say anything to that.
That's what the hot circle was in the middle of one of those slides that was more in the Highlands area?
So the hot circle was the Lake Nepean one. This hot circle in the middle is the Upper Nepean 1 borehole. That was from 1980 and was the one that first progressed this study. It was around 30 degrees, I believe. It used to be AGL who owned the borehole. So they're the ones who drilled it as an exploration sort of borehole. Yeah, Bargo would be near one. It would have been roughly 300 metres. This research isn't just going to be sitting here. There's currently a PhD student expanding on this research in a more nationwide study. All the authors on the paper, including myself, have just reviewed it, and so he's hopefully going to be submitting that soon. So I think it'd be great for him to come and talk to you guys too when he's finished his PhD, because he expands on what I did a lot more, and I think you'd all be interested in what he has to say.